Welcome everyone. In today's video, we are going to see we were going to see about object-oriented programming. So here, what is the basic aim of OOPS? So the basic aim is to implement real-world entities like inheritance. Suppose you are inheriting something from your parents or grandparents, or hiding. You want to hide something, or polymorphism, that is the same name but which has different meaning. So these types of concepts which belongs to the real world, you can implement it using programming. That is what is object oriented programming. So here we bind together the data and the functions that operate on them, so that no other part of the code can be accessed access this data except that function. So here we are going to see the basic concepts of OOPS, which includes class, objects, encapsulation, abstraction, polymorphism, inheritance, dynamic binding, and message passing. So we will be going through each of them one by one. Now let's see what is a class. Okay, so class is a user defined data type that has data members and member functions. So you can consider class similar to a structure if you have studied structure earlier. So it is user defined. We define it. The user defines the class, and it has data members. Data members you can say as the variables, and member functions you can say it as functions. Okay, the names are for variables, we are referring it as data members, and for normal functions, we are telling it member functions. Okay, so it can be accessed and used by creating an instance of that class. A class is like a blueprint of for an object. So I will explain it. What does it mean? And then data members and member functions defines the properties and behaviors of the objects in a class. Okay, now to understand these lines, let us consider a simple example. Okay, we all love cars, right? So consider a class of cars. Okay, now each and every cars will be having different features. Means speed limit will be different, then mileage range will be different, but all the cars have some basic, the blueprint of all the cars is almost same, right? They will be having four wheels, they will be having some speed limit, they will be having mileage. So these are the features which all the cars have in common. So you can say that is the blueprint of the car, which we call it as class. Okay, now what can be the data members or variables of this class called cars? We can give the data members as speed limit, mileage, maybe color, etc. Right? And what can be the member functions? That is what the car class can do. So it can apply brakes, it can increase the size. So these can be the member functions of the class. Now, if we create, so this is the blueprint is the class, is the car, and then now if we create an instance of that car, then it will be known as the object. Now the instance of the class can have a specific color, a specific speed limit. So like that we can create many objects having from the same class. So just now I explained what is an object. So it is an instance of a class. So the car class that we have created, so for that we can create objects for that particular class car, okay, which will contain specific, if we consider the data members, so it will consider specific color, specific speed limit, and specific mileage, etc. Okay. Now one more thing, interesting thing to understand is that when a class, if you see point number 3, when a class is defined, no memory is allocated. But when it is instantiated, that is the object is created, memory is allocated at that time only. Okay. And then the program, and when a program is executed, the objects can interact with each other by sending messages. And each object contains data and code to manipulate the data. Okay. Now next one is basic concept is encapsulation. So here in OOPS, encapsulation comes in the form of class. So what it is basically the wrapping up of data and information under a single unit. Okay, so it leads to data abstraction or data hiding. That is, one class cannot directly see the what is present in another class. That is, data hiding is presented. So I will try to explain it with the help of a simple example. So now consider a company. Okay, so in a company there are different departments like account department, finance department, sales section, etc., right? So now there, suppose an official from the finance section needs some data from the sales section. Okay, now he cannot directly, the finance section directly cannot access the data from sales section, right? So they will have to first request for the data to sales section, and then upon receiving the request, the sales section will provide the data to finance section. So that is so this way process that is being done, it provides what? Data abstraction or data hiding. The same thing is done in encapsulation also. So we can provide that facility in OOPS also. Okay, so the next concept is data abstraction. So what is abstraction? It means we are going to provide only the essential information about the data to the outside world. We will not provide the background details or the implementation part. Now, if we consider a small example, say you are driving a car, okay? So you know that pressing the accelerator will increase the speed, or by applying brakes, you can slow down the car, but you are not bothered about but what is the actual mechanism going inside the car. So this is what is abstraction. So this abstraction is given in when you're using OOPS concept. So it is provided in class with the help of the access specifiers, which we'll be studying later on, like private, public, or protected. So it gives how much data you want to show to the outside world. Similarly, abstraction is present in the header files also. So if you're going to use the header file math.h, it is having a function say POW, where you find out the power of a particular number. So when you call the function, you directly you are able to know the power of a particular number. You are not bothered about what is the calculation going on inside. So this is also an example of abstraction. Next concept is polymorphism. So from the name itself, it is clear. Poly means many and morphism means forms. That is same name and many forms. So it is the ability of a message to be displayed in more than one form. Okay. So there may be a behavior. The behavior may change depending on the type of data used in the operation. So for example, a man can, if we take a real life example, so a man can be a father, husband, or an employee at the same time. The person is same, but he is performing different roles considering different situations. So the same thing can be applied in programming also. And in C++, this is achieved with the help of operator overloading and function overloading. So in operator overloading, you will be having an operator which will exhibit different operations depending on different situations. Similarly, function overloading, the name of the function will be same, but it will perform different functions depending on the return type and the number of arguments present in the function. Example of polymorphism. Okay, so you see here we have a like function sum, where we are giving passing two parameters 20 and 30, and another function we are having sum, again the name is sum, but here we are passing three parameters, that is 20, 30, and 40. So both the functions perform the same task of performing the finding the sum of numbers, but in the first case it is trying to find the sum of two numbers, and in the second case it is trying to find out the sum of three numbers. The concept is inheritance. Okay, so in simple terms, if we see inheritance, what is inheritance? That is, we're inheriting something from our parents or grandparents. So that is the capability of a class to derive properties and characteristics from another class. Now if you see the simple example, so we have the animal class. So in animal class, we will be having the general data members and data functions. Okay, so it will be having the general characteristics. Then from this animal class, we have the subclass, which are the or the derived class, which are say dog, cat, and cow. So these will be having the basic animal class properties like um, whether they vegetarian or non carnivorous, something like that. Okay, the way of eating the food, then land animal, water animal, all these things will be the general things will be there. Now the specific things will be there in the cow class, cat class, and dog class. So from the in dog class also it will be having some varieties or characteristics which are present in the dog, which are present in the dog only. So it's like that the subclass are created from the basic base class, animal class, right? So this animal class is known as the superclass, and this dog, cat, and cow are known as the subclass. Now, this concept of inheritance is very important as it supports reusability because the characteristics or variables and data functions that we will be member functions we will be describing in the animal class, we need not define it again in the subclasses. So it will inherit all the properties of the animal class. So it supports the concept of reusability. The next important concept is dynamic binding. Okay, so the code to be executed in response to the function call is decided at runtime. So we don't do it beforehand. At the runtime, we will be executing the code for the function call. And in order to achieve this dynamic binding in C++, we have something called virtual functions, which supports the dynamic binding. So why we need this dynamic binding? Because it is very flexible, and whatever drawbacks that are faced using static binding, these are so to compensate with these drawbacks, we go for dynamic binding. Okay, so the final concept is message passing. Okay, so here the objects communicate with one another by sending and receiving informations. So this is how the objects communicate with each other. So a message for an object, what is a message? So a message for an object is a request for the execution of a procedure or a function, and therefore it will invoke a function in the receiving object that generates the desired results. So one object will request for some procedure, and to in order to execute that procedure in the other object, it will invoke the function that performs that particular task. Okay, so message passing involves specifying the name of the object, the name of the function, and the information to be sent. So this is all about the basic concepts of OOPS. Thank you, everyone.